We're demonstrating the shadowgraph technique used to measure striae within the bulk of precision optics. On the left, we have a Class 1 Grade D optical window, and on the right, we have a Class 5 Grade A optical window. And these two optics are located in the same plane on a table, and a point source, such as a flashlight or a fiber scope, is located a distance in front of them such that it projects a diverging beam of light on a wall, and this casts a shadow on the wall of the two optics under test. And you can see the Class 1 Grade D optic has a number of different striae and patterns in its shadow, and the Class 5 Grade A has no visible patterns to its shadow at all. So this is how we can actually qualify the striae within the material. If we wanted to quantify the size of the striae, we would locate in the exact same plane a caliper that has its jaws separated by a known amount. In this case, I've put this caliper at a separation of 3 millimeters, so now we have a 3 millimeter reference in the same plane, so that any defect in the shadow plane that has a separation equivalent to that of the caliper equals 3 millimeters. We can also look through the bulk of the material, and we can see that the distribution of the striae changes as we rotate the material to an angle of about 30 degrees in that case. So you saw the shadow graph of the striae change its distribution as I rotated that optic. However, with the Class 5 Grade A optic, as I rotate that, you don't see any discernible striae distribution. It's also important to note that when you're doing the shadowgraph test, it is imperative to test flat optical windows. If you wanted to test a lens, if you look at the single element lens, you'd notice that it's very difficult to get a shadowgraph through the lens because the lens is actually focusing and expanding the light. A similar effect happens with prisms, whereas if we take a prism, like this twisted poro prism, the light is actually reflected through the surfaces of this twisted poro and does not cast a shadow either. And here's another Class 4 Grade B material where you can rotate this material through various angles and see some striae within its shadow graph. However, it is important to note that this is much more similar to the Class 5 Grade A material. It is relatively striae free.